When you imagine an airplane, most likely images of impressive engines, gigantic wings, or a cockpit filled with numerous instruments and screens come to mind. But have you ever thought about those tiny yet incredibly important parts that always remain behind the scenes, the airplane wheels? Yes, those very wheels that seem tiny compared to the majestic body of the aircraft, yet are capable of withstanding incredible loads, tons of metal, and the insane speed during landing that would cause ordinary car tires to explode. How do these wheels manage not to burst under such extreme conditions? And here's another curious question. What is the price of one such wheel? Let's delve into 10 of the most interesting facts about airplane wheels and immerse ourselves in the world of aviation. Why don't airplane wheels explode upon landing? Let's start with the most impressive and thrilling moment. When a multi-ton aircraft touches the runway, its speed can exceed 250 kilometers per hour, and the total weight can reach 560 tons, like the giant Airbus A380. For comparison, if a car were to hit a hard surface at such speed, its tires would burst in an instant. However, nothing of the sort happens with an airplane. What's the secret? It's all about the material from which airplane tires are made. They are crafted from synthetic, ultra-durable rubber, reinforced with several layers of nylon and Kevlar, the same material used in bulletproof vests. This unique construction allows the tires to withstand not only enormous weight, but also sharp temperature and pressure fluctuations. To understand the scale, one airplane wheel can withstand up to 38 times more pressure than a standard car tire. And even after dozens, if not hundreds of landings, it retains its shape and integrity, continuing to serve faithfully. Now let's move on to the question of what fills airplane wheels. If you thought that airplane tires use regular air like in a car, that's not the case. In fact, they are filled with pure nitrogen. But why nitrogen? Firstly, nitrogen does not expand when heated as air does. This is extremely important because during landing, the wheels heat up to extreme temperatures and any gas expansion could lead to a catastrophic explosion. Secondly, nitrogen contains no moisture or oxygen, which can cause corrosion of the metal parts of the wheel. Thanks to this, the internal surface of the tires remains in perfect condition for longer, extending their lifespan. Thirdly, nitrogen maintains stability under extreme pressures and temperatures, retaining its properties even at an altitude of 10 kilometers, where the outside temperature can drop below 50 degrees Celsius. So when you see a technician inflating airplane wheels, know that he is using not an ordinary compressor, but a special high-pressure nitrogen tank. And here's the most astonishing fact. How much does one airplane wheel cost? If you ever thought car tires were expensive, get ready to be surprised. The price of one airplane tire ranges from $5,000 to $20,000, depending on the aircraft model. For example, a Boeing 747 has 18 wheels, and the legendary An-225 Maria has as many as 32 wheels. Can you imagine how much it costs to replace the entire set? And that's not all. Tires need to be replaced quite often, every 300 or 400 landings. And considering that major airlines perform thousands of flights a month, just replacing tires costs millions of dollars a year. Yes, wheels are not just a part. They are a crucial element of flight safety, and no expense is spared on them. Now imagine how airplane wheels are changed. If you've seen how a car tire is changed at a service station, the process of replacing airplane wheels is a level of extreme professionalism. First, the landing gear is lifted using powerful hydraulic jacks. Then the pressure is released from the tire to prevent it from exploding during removal, as there are still dozens of atmospheres inside it. After that, special equipment is used because one wheel weighs from 100 to 200 kilograms. A new tire is installed and reinflated with high-pressure nitrogen. All this is done as quickly as possible because airplanes fly on schedule, and downtime at the airport costs a lot of money. Have you ever wondered why airplanes need so many wheels? If a car manages with 4, why does an airplane have 6, 10, 18, or even more wheels? The answer lies in weight distribution. Take, for example, the Boeing 747. At takeoff, it weighs about 400 tons. If it only had 4 wheels, they would simply sink into the asphalt. The more wheels there are, the more evenly the pressure is distributed on the runway. This protects the surface from damage and makes the landing stable and safe. Interestingly, it sometimes seems like the wheels start spinning before they touch down. If you've ever watched a plane landing in slow motion, you might have noticed a strange effect, as if the wheels begin to spin before they touch the ground. In reality, this is just an optical illusion. It is created by the frame rate of the video camera and the speed of the aircraft. To the eye, It looks like the tires are already spinning, although in fact, they start rotating only at the moment of contact with the ground when immense friction is applied to them. What happens if a tire bursts during landing? Such cases are extremely rare, but they cannot be completely ruled out. Despite all the safety measures taken, sometimes circumstances arise where an airplane tire can burst. This can happen for a number of reasons, such as overheating, material fatigue, or hitting a foreign object. However, it is worth noting that the aircraft's design initially takes such risks into account. Firstly, airplane tires have a multi-layered reinforced structure. This means that even when they burst, they do not shatter into pieces but maintain their shape, managing the impact energy. Secondly, airplanes are equipped with numerous wheels, allowing the load to be distributed evenly. If one tire fails, the remaining wheels take over its function, ensuring safety and stability. Thirdly, landing gear struts are meticulously designed. They can effectively absorb the impact and maintain the aircraft's stability, even if the pressure in one of the tires suddenly drops. History knows many cases where planes successfully landed on several damaged tires and still managed to brake successfully, maintaining balance. This once again highlights how well thought out and reliable modern aviation engineering is. How do airplanes brake? And why don't they use the regular brakes we know from cars? After landing, the airplane's wheels, in addition to absorbing the impact upon ground contact, must stop this massive metal structure rushing at over 200 kilometers per hour. For this, airplanes use special carbon brake discs that can withstand extreme temperatures exceeding 1,000 degrees Celsius without deforming. When the pilot presses the brake pedals, special hydraulic systems activate the pads, which press against the discs, creating enormous friction. Sometimes you can see smoke rising from under the plane, but this is not a sign of malfunction. It's simply the result of the brakes heating up to incredible temperatures. To reduce the load on the braking system, airplanes are also equipped with spoilers, movable flaps on the wings that create additional air resistance and reduce lift. Another important element is the thrust reversers, which redirect the airflow forward, helping to slow down the movement. Thanks to this, the plane slows down faster and more safely, not relying solely on its wheels. So what happens to old aircraft tires when their service life comes to an end? They are inspected just like regular car tires. After each landing cycle, specialists carefully examine the wheels, checking for cracks, wear levels, as well as pressure and air tightness. If the tire wear reaches the maximum allowable mark, they are removed and sent either for recycling or restoration. Some tires, after repair, undergo testing and return to service. Others find applications in various fields, becoming part of safety barriers at airfields or are used on training grounds and racetracks. Sometimes they are even adapted for playgrounds and decorative purposes. Thus, even after their last landing, tires get a second life and continue to serve society. Why do aircraft wheels seem so small compared to the massive body of the aircraft? It may seem illogical, as the wheel sizes at first glance appear too small for such a massive structure. However, everything has its explanation, and the main reason lies in aerodynamics and design constraints. Larger wheels would increase the overall weight of the aircraft, increase air resistance, and create difficulties with their placement inside the fuselage. After all, the landing gear must fully retract to not interfere with the aerodynamic properties of the flight. Therefore, engineers resort to alternative solutions. They make the wheels more durable and resilient, designed for high pressure, but keep them compact in size. One such small wheel can withstand loads of tens of tons while remaining lightweight and technologically advanced. Aircraft wheels are perhaps one of the most underrated components in aviation. They absorb colossal forces during takeoff and landing, withstand extreme temperatures, pressure, and friction that cars can only dream of. Every detail, from the rubber composition to the method of nitrogen inflation, is calculated with precision down to the smallest nuances. And all this is for one purpose: to ensure the safety and smoothness of landing for hundreds of thousands of passengers. Next time you see a plane gently touch down on the runway, remember that these seemingly inconspicuous wheels are doing truly gigantic work, ensuring a safe arrival at the destination.